Let's go now to an exercise. This time I'm putting you in the position of being a merchant, mixing some things to sell to your customers. You are a coffee distributor. A coffee distributor mixes coffee that is 60% Colombian with 70 pounds of coffee that is 80% Colombian to make a blend that is 74% Colombian. How much of the 60% Colombian coffee is used? A coffee distributor mixes coffee that is 60% Colombian with 70 pounds of coffee that is 80% Colombian to make a blend that is 74% Colombian. How much of the 60% Colombian coffee is used? After you've copied this exercise, be sure all the numbers are right. After you've copied the exercise, stop the tape, work the problem, then restart the tape to check your answers. In your answers, you should indicate the system of equations that you set up and the final answer to the question. Here's your answer. The equations are x plus 70 equals y, 0.60x plus 56 equals 0.74y. Your answer is 30 pounds of the 60% Colombian coffee. If you miss the problem and cannot find your mistake, be sure to mark your paper so that you can ask for help when you go to the lab. We turn now to the problems of rate of wind or rate of current. These are based on the distance formula. The distance formula is a standard formula that you should have been exposed to before now. So I'm going to review it with you, assuming that you have seen it already. The distance formula says rate times time equals distance. Rate times time equals distance. This is one that you must know by heart. It's one that is a very useful formula because we all travel one way or another. We walk, we ride in a car, bus, plane, canoe, motorboat, all kinds of craft. But whatever mode of transportation we have, this same formula applies. The rate times time equals distance. The rate means how fast it goes. The rate is how fast it goes. It might be in miles per hour. It might be in centimeters per second, and so on. Rate is how fast it goes. Time is how long it travels. Time, how long it travels. If the rate is in miles per hour, then that means the time for that problem would be in hours. If the rate is centimeters per second, that means the time would be in seconds. So the time might be in hours, it might be in seconds, and so on. The distance is simply how far it goes. The distance is how far it goes. If the rate is in miles per hour and the time is in hours, then the distance would be in miles. If the rate is in centimeters per second and the time is in seconds, then the distance would be in centimeters. So the distance might be in miles, it might be in centimeters, and so on. Now let's think about what happens when a craft is moving along and something interferes with it. We're going to look at the idea of an airplane moving along. Here's our airplane. The airplane flies along and it's going at whatever the rate of the craft is moving it. But what happens when there's wind? If the plane is going in the direction I have it pointed now, and there is wind that is also going in that same direction, then what does that mean? The plane is moving along, the wind is going in the same direction, then the wind will push the plane faster. The wind is going in the same direction as the plane, it will push the plane faster. If the wind continues blowing in this direction, and the plane on the return trip encounters the same wind, what's going to happen? This time, the wind will slow the plane down. The wind is working against the plane. So we have the plane moving along, but the wind pushing against it. That means that the plane will still get there, but it'll be slower. It'll take longer to get there. We have a similar situation on water. If you've canoed on one of the beautiful rivers in Rockingham County, on the Dan or the Mayo or the Smith, which way would you rather go? Would you rather go upstream or downstream? Well, of course you'd rather go downstream. Why? Because on that river there is a current that is moving along. I don't have a canoe here, I have a little motorboat. Here's the front of the motorboat. If the current and the boat are working together, then that means the boat will go faster. The boat would be moving along at its rate, and the current would increase its rate and make it go faster in that direction. But on the return trip, when the boat comes against the current will slow it down. So here's the boat trying to go upstream, the current is pushing it downstream, and it's going to slow the boat down. If you've ever tried to paddle a canoe upstream on a river that's moving along at a fairly stiff rate, you probably have experienced what I have, and that is being pushed backward. The only way the boat's going to make it is to go faster than the current is. Otherwise, it will be pushed downstream. The same thing, of course, happens with a plane, but we won't talk about the consequences there. Well, the result of this is, if the craft is traveling with the wind or current, if the craft is traveling with the wind or current, then the rate of the craft plus the rate of the wind or current is the rate that it will actually move. Traveling with the wind or current, we add the rates of the craft itself, the boat or plane, and the wind or current. Traveling against the wind or current, we have the rate of the craft minus the rate of the wind or current. Traveling against the wind or current, the rate of the craft minus the rate of the wind or current. Let me see if I can get both of these on here. Not quite. Traveling with the wind, the craft is trying to go this way, and the wind or current is trying to go this way. They're working together, and so we add up their rates. When the craft is going against the wind or current, the craft is going this way, the wind or current is going that way, they're working against each other, and so we subtract their rates.